Okay, hi my gems. Today we are going to talk a little bit about data and choosing the correct data display depending on what kind of data it is that you're looking at. So we're going to be choosing an appropriate method, whether it's numerical or categorical data. So if it is numerical data, obviously the way it sounds, right, that means we are using some kind of number. Categorical data is really way more about different categories, right? So talking about like, oh, do you like books or movies or different types of, anything of that realm that's a category would be a categorical data. So when we're looking at numerical data, right, just numbers, there's typically three ways that we're going to look at plotting that data. A line plot, right, that shows clusters, gaps, and outliers within a data set. So here's a little picture of what a graph of that could look like. A histogram, which does not show individual values, but does show like an overall shape of what the data looks like. The data is also organized in intervals, right? So posts per day, you'll see down here on this histogram, right? Like this is between 6 and 7. I don't know, my thing's not drawing. Or between 8 and 9, right? So it's giving intervals. Last one is box plot, which shows the center or the median and the spread of the distribution. It'll also give you the minimum and maximum values, as well as the median and the different quartiles. If we're looking at categorical data, again, organized by category, we can use a line plot for categorical data as well. It is an easy way to see like the greatest number of data points, right? So for this particular one, it's very easy to see that car, for whatever this category is, would be the highest data point. Circle graph is used really when we talk about the frequency of data. So how often is something happening? Obviously, you see it a lot with percentages, again, categories with the total data set. And then the last type is a bar graph, which displays frequencies or relative frequencies. So can be used to make some predictions about similar data sets. So it's probably stuff you're already very familiar with, but again, it's just a nice quick review. Okay, so let's take a look at a couple examples. Number one, Maribel asked a random group of upper class students at her school which grade they were in and how they travel to school in the morning. The data that's shown in the segmented bar chart over on the right. Which pair of terms best describes the data? So I see I either have bivariate for the first two choices, or I have univariate for the second two. Bivariate, think about a bicycle. It means you have two different variables that you're looking at, whereas obviously univariate, again, think about like a unicycle. It's got one wheel, right? That means one, you only have one variable if it's one variable, okay? Now, the other part, of course, is it numerical or categorical? So can it be fit into categories, or is it all based on like how, like the number of something? So like number of inches, number of feet, something like that. Okay, so if I'm looking at a random group of students, I want to know both what grade are they in and how they travel to school in the morning. So that's two different things I'm looking at. What grade are they in and how are they traveling? So already that tells me my answer needs to be one of these two at the top, bivariate. It's not going to be univariate. Okay. Then as I'm looking here, I go, okay, am I looking at numerical data or am I looking at categorical data? So data that's put into different categories. And very obviously, bus, car, walk, all of those are different categories. So this is categorical data. So my answer is bivariate and categorical. Easy peasy. On to the next one. Okay, number two. The histogram shows the efficiency level in miles per gallon of 110 cars. Okay, so I've got miles per gallon on the bottom. Frequency is how often, like what's the number of times that something happens. But I'm only talking about one variable, which is how many miles per gallon can I get with each car? So because I'm only talking about one thing, this is definitely going to be univariate data, right? I'm only talking about miles. Is my data numerical, or categorical? Well, I'm talking about miles, and I'm talking about how often are those miles happening, right? What's the frequency? What's the rate? So because of that, I am looking at numerical data. So this is univariate and numerical data. So next part says, how many cars have an efficiency between 15 and 20 miles per gallon? So this is my range between 15 and 20. All I do is I come between here, right? So this is my part of the histogram. I come all the way up to the top, and if I look over, I see frequency right there. It's at 35. So 35 cars have an efficiency between 15 and 20 miles per gallon. So easy, right? Like almost too easy. You're like, Damaso, this is too simple. Okay. How many cars have an efficiency more than 20 miles per gallon? More than 20. So that would be, I can't use these numbers here, right? Between that I just did, between 15 and 20, because this is asking me for more than 20. So I really want this section here between 20 and 25. And I also want this section here between 25 and 30. So this green section here, if I come over to the frequency, this is 25. Right, little friend. My other one, this blue one over here, if I look at the frequency, there's 15 within that range. So how many cars have an efficiency more than 20 miles per gallon? That would be 25 plus 15, which gives me 40. So 40 cars have an efficiency more than 20 miles per gallon. Last one, what percentage of cars have an efficiency less than 20 miles per gallon? So it's the same idea. I'm going to do less than 20. Okay. So that would be, if it's less than 20, right? That gives me this section here. I'm coloring in orange, right? Between 15 and 20. That gives me this section, and that gives me this section. So all of these would be less than 20 miles per gallon. So if I just look at their frequencies again, this is 35. This frequency is 20. This frequency is 15. So I want to know, okay, how many is that? All I have to do is add them up, right? So I add up 15, 20, and 35. But what's important here is that it's asking me for percentage, right? It's not just asking me for the number, how many. It's asking me for a percentage. So I need to say, okay, I'm going to add up this 15, this 20, and this 35. I get a total of 70. That's my frequency. But to make it a percentage, I need to do out of how many are there in total. So in total, my number would be, to get the total, I'd have to add all these orange frequencies and the purple frequencies together. So I'm going to add together 15, 20, 35, 25, and 15. And when I do that, I get 110. So to find the percentage of cars that have an efficiency less than 20 miles per gallon, it is 70 out of my 110, which gives me approximately 0.636. And if I want to change that into a percentage, I just move the decimal 2 places to the right. So it's about 63.6% is my final answer. Or if I want to round it up, because I think the question online is going to make you do it as a whole percent, it's about 64%. Okay, so be very careful to make sure you're looking at if it's asking how many or if it's asking a percentage. So that's it. And now you've done 2 data questions. Oh my gosh, so smart. Last one. A teacher collects data on the number of points his students earned on a quiz out of 20 points. The data is shown on the line plot below. Which box plot could also represent the data? So I have 4 box plots over here. And this is now, because I'm looking at a box plot, I'm looking at something called the 5-number summary. And you've probably seen this before in like your younger classes, and I know you have. The 5-number summary is 5 different numbers that show like the overall display of your data. So you've got a minimum range, a minimum. You've got your first quartile, quartile 1, which is kind of like your median of the first quartile. You've got, of course, your median itself. You've got quartile 3, and you've also got your maximum. Now, if you know these pieces, these are the 5 things that will get drawn on our box plot. So minimum is just obviously what is the smallest data point that you see. Smallest data point I see is 6. And my maximum, my largest one I see is this one right here, which is really at 19. So my maximum's at 19. So when I go to draw my box plot, there should be a line at the minimum and a line at the maximum. So already I'm going to look at my choices and see, do any of them have a choice between 6 and 19 should be where it is. So this one looks like it's okay. Letter A is fine. Letter B is not. I can already see. Letter C is not. Oh my gosh, look at that. Letter D doesn't work either. I only have one choice, which is letter A. This one right here. So this line, this is my minimum. This line over here is my maximum. And I'm still going to show you how to get the other ones just because you'll obviously need to be able to get there at some point. So the median point means the number at the value that's at the very middle of your data points. So what you can do to get the median is just, what I like to do is I cross off points on the left and on the right, and I do it at the same rate. So for example, cross off the 6. I'm also going to cross off the 19. I'm trying to get to the middle point. That's going to be my median. I cross off 1, 2, 1, 2, 1, 1, 1, 2, 1, 2, 1, 1, 1, 1, dun, dun, dun. Look at this. I'm between 12 and 12. So those are my last 2. The number in between 12 and 12, is 12. So my median is at 12. So on my line here, you see how this one, here's my 12. This is your median. Okay. Now, quartile 1 and quartile 3 is the exact same thing I just did for the median, except quartile 1 means you do it for the lower half of your data. This is quartile 1. And then obviously the larger one would be quartile 3. It's the exact same thing. You go from the minimum to the median and you just cross off until you get to the center. So that being said, I'm going to erase these marks and I'm going to cross off exactly like I just did. Okay, but here's where it kind of eggs off. Okay, so 1, look at that. The 2 of them are in between. I'm at 9 for my quartile 1, and then I'm going to do the exact same thing for my quartile 3, just crossing them off one by one, so easy. So I go 12 is gone, 19, 1, 1, 1, 1, 1, 1. Okay, I'm left with right here at 16. So my quartile 1 should be at 9, and my quartile 3 right here, that's my Q3, is at 16. My quartile 1 was this one right here, is at 9. So A is the correct answer for my box and whisker. Okay, so now we've done data. Go ahead and pause the video and try the examples on your own. Have a great time. Okay.